All right, this is number 5. This is still the 2014 exam. So 4 and 5, we should be doing both of these on Tuesday. 7 minutes apiece. You set your egg timer for 7 minutes. It dings, you're all done. This is an interesting little question. It talks about a student making a hypothesis, and anytime a student's doing anything, we can expect some error in that. And so anytime I'm doing something, you can expect some error too, for that matter. And so when we look at this thing, understand it's a student's hypothesis, and ask us a couple quick questions about it. So we'll see how this goes. Here we go. 5A says some binary compounds form between fluorine and chloride and various nonmetals, and they're listed in the table above. Student looks at the table. He comes up with the following hypothesis: the number of fluorines that bond to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. And so when we look at this, 8 minus carbon has 4 valence electrons. There should be 8 minus 4 is 4 fluorines. Nitrogen has 5 valence electrons, so 8 minus 5 gives us 3. There should be 3 fluorines, and so on. And he looks at the first period of the periodic table and then the second period of the periodic table, and it looks the same. So it says, based on the student's hypothesis, what should be the formula for the compound that forms between chlorine and fluorine? You don't have to show a bunch of work here. You should understand that chlorine is going to be the next one sitting to sulfur, and they've kind of gone down the list here. It has 7 valence electrons, so 8 minus 7 means that our formula between chlorine and fluorine should just have 1 fluorine attached to that chlorine. So I wrote it that way. That's the answer to part A. There should just be 1 fluorine attached to it. Part B says, in an attempt to verify this hypothesis, the student researches fluoride compounds and finds a formula of ClF3. In the box below, draw a complete Lewis dot diagram for the molecule of ClF3. Ooh, fun times. A Lewis structure. I'm hoping somewhere that you're gonna have to draw a Lewis structure. We'll see what happens. So it's the least electronegative element goes in the middle. So chlorine will have to go in the middle, which means the fluorines are going to be around that chlorine somewhere. I have a little head start in knowing where those fluorines are going to kind of face along the way, and you may not, and that's okay. Scatter those fluorines around that chlorine, and then we've got to add up electrons around this guy. So when we add up electrons, they each have 7 valence electrons. So we've got 28 total electrons, or 14 pairs of electrons. And so there are our first 3. 1, 2, 3 pairs. And then we come back and we put the pairs on the terminal atoms that we need. And so all of those fluorines we call terminal atoms. And we're going to get those lone pairs around those terminal atoms. When we total them up, we got 3, 6, 9, 10, 11, 12 pairs. We have 2 pairs left over, and so those 2 pairs, if we have extra pairs and the terminal atoms are filled up, we put those extra lone pairs on the central atom. And so our drawing or our structure looks like that. How many domains? 5 domains, 2 lone pairs. This is head and feet. We talked about this in class. Head and feet in a triangular hula hoop, right, where we've lost a couple of the hula hoops. Good? And so we should know the shape of this going into part C. That's your structure, that's your point for part B. We should know the shape going into part C already. Man, they help us out a ton in this question. And so if you know it already, then this is all bonus for you. It says 2 possible geometric shapes for the chlorine trifluoride molecule are trigonal planar and T-shaped. Good? If you got head and feet and 1 hula hoop piece left, then we should know this is T-shaped. And so this is going to be a T-shaped molecule. It says the student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with that dipole moment? And justify your answer in terms of bond polarity and molecular structure. And so the answer is, to the first question, which of these 2 shapes is consistent? Our answer should be T-shaped. And this is an opportunity at home when you got some spare time. Go back and look up the shapes and make sure you're comfortable with all of them. Try to draw them in 3 dimensions. Make sure you're happy with that. So this is T-shaped. It says justify your answer in terms of bond polarity and molecular structure. So the reason it's T-shaped is because the fluorines are more polar. More electronegative is probably the better answer. More electronegative. Causing bonds to be polar. The lone pairs don't allow dipole moments to cancel. There are other ways to say that, but that's probably what you're looking for. The bond polarities, right? We talked about it. The bonds are polar. In molecular structure, the lone pairs in that structure are what don't allow those dipole moments to cancel. And so that's our answer to part C. Make sure you answer the question. Make sure you call it T-shaped before you move on. But you only get 1 point for part C. And then part D, at the end, an attempt to resolve the problems that the student created. The student researches compounds that form between halogens and fluorine and assembles the following list. So we got all these halogens. It says, based on the concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the compounds that form between halogens and fluorine. So now they're asking you to make a some kind of hypothesis about these things. And whether your hypotheses are true or not, it doesn't matter as long as it backs up this data. What do we see when these halogens bond to the fluorines? Every one of those numbers of fluorines that it bonds to is odd. And so the hypothesis they were looking for is that halogens bonded to fluorines should be or should have odd numbers of fluorine. That's it. It's a weird little question, but you see little weird questions once in a while. So there you go. There are some points to be won here. You guys should be able to get the first one. That's a free point. The second one, you need to be able to draw that structure, which at this point we can. And then a couple little weird kind of answers at the last part. I think this one is a freebie though. You can get that point for sure. And then it's just using the right verbiage there in part C. So there's Tuesday. Hopefully you already saw 4. This is 5. Make sure you're working these before you watch the videos, so that you get a chance to compare your answers instead of thinking in your head you would have gotten all the points for them. We'll talk to you later. Bye.